everyone, it's Jess Minniquack, and I am recording my Module 5 Inquiry STEM activity titled Liquid Layers in Motion. So for this activity, students will explore liquid density, and I'm giving them some questions for exploration. So I used the figure 5.2, the conceptual framework, for asking questions to engage, explore, and explain, and then elaborate as I created these questions. So students will first explore what do you think will happen when you pour liquids into the same container. Then they will explore can we change the order of the liquids, and then students will explore how temperature can be used to change the order of the liquids. So here are screenshots of the student handout that I created that students will complete as they do this activity. So for starters, students will have their materials. I chose a list of 7 materials. With your class, if you were doing this, you could brainstorm a list together and either you could provide the materials or students could bring them in. So for this activity, I used water, vegetable oil, honey, soda, dish soap, maple syrup, and orange juice. And I measured 60 milliliters of each liquid. So as you can see, I created my sketch to predict what would happen, and I predict that the liquid layers, they would form layers and the liquids would not mix together. As you can see, for each step, what happened when I added the water, then oil, then orange juice, then the honey, the root beer for the soda, syrup, and then ultimately the dish soap. And you can see the very distinct layers for each liquid. In the middle, you can see there is the root beer and the water is a little bit mixed together. They had a similar density, but other than that, the layers are fairly distinct. So then I explored if I could change the liquid layers, because we know that the liquids have different densities. So now I looked at honey because that was at the bottom and oil because that was at the top. And so I started here with a fresh mixture here, and then I heated without the honey and without oil. And I heated the honey in the microwave for 1 minute to increase the temperature. In my classroom, I would use a probe thermometer that students could get an exact temperature. We just used the regular scan body thermometer. That's all I had at home, so it just said high for the temperature. And then I poured the honey into the mixture, and you can see at the top it formed like bubbles, and then you can see it mixing in here with the dish soap. For the oil, I placed it in the fridge, and the original temperatures were around 72 degrees, so then they went down to 61 after it was in the fridge for 15 minutes to decrease the temperature. And you can see it appeared thicker than before in the pictures, and more of it is settled down into the middle of the cup. You have to look at it very closely because once you let the liquids sit for a minute, they return to their original positions, either at the top for low density or the bottom for high density. So students from this activity will take away that students will learn that liquids have different densities. Density is calculated by dividing mass by volume, and therefore the mass in regards to volume changes, the density of the liquid changes as well, and changing the temperature of the liquid will change how the particles move. That the heated liquids move faster and the particles in cooler water move slower. So my STEM perspective for this activity was integrated disciplines, because there are elements of science, technology, engineering, and math. So students are exploring density for science. They're comparing states of matter. Technology, they're comparing the characteristics. Students use technology to heat cool liquids and the digital thermometer. Engineering, they're constructing a model to represent liquid density, and they're brainstorming, sketching, and revising ideas. And then for mathematics, students are measuring liquids using division and taking the temperatures. So here is my 6.2 incorporation of behaviors incorporating science and engineering for mathematics, and you can pause this to read it, or I will include I'll include my PowerPoint, and the same thing for 6.3. Here are my references. I hope you guys enjoyed.